Okay, this is lesson 5.1, trigonometric ratios. Before we get into the new content, we have to recall or activate some prior knowledge. The first thing we need to review is how to name the parts of a right triangle and then some ratios and properties of right triangles. So let's first look at a right triangle. We know this is a right triangle because we have a 90-degree angle. In our right triangle, we might have a reference angle, and we use the Greek letter theta for a reference angle. And from our reference angle, we can name the three sides of our triangle. But before we name the sides, let's name this triangle ABC. A, B, C. So we can name the three sides. Aside from giving this side A, side B, and side C, we can name it with the words opposite, adjacent, and hypotenuse. Opposite, adjacent, and hypotenuse. And hypotenuse is the one across from 90 degrees, or across from the right angle. Adjacent means next to. It is next to the reference angle. And opposite means across from. Always in terms of the reference angle. So if we look at our triangle, the easiest one to name is the hypotenuse. So we'll start by labeling the hypotenuse. And the hypotenuse will be the one opposite or across from the 90, the longest side. And I'm going to put an H and I'm going to box it just so that letter doesn't get confused with any of the other letters on the triangle. After naming side H, the other easy one to name would be the adjacent because it's the other side that's touching the reference angle. The reference angle is always made up of two sides, this side and the hypotenuse. The hypotenuse will always be one of the sides touching a reference angle, and the adjacent will always be the other one, the next to. And opposite should be the one across from the reference angle, and that's the side that's not touching the reference angle, and in that case that's this side over here, and that is the opposite side. So one of the required pieces from last year is your ability to draw a triangle ABC that's a right angle and then label it with OA and H, opposite, adjacent, and hypotenuse. The next piece that we need to recall is what the Pythagorean theorem is. And we can use the Pythagorean theorem only in right triangles. And the Pythagorean theorem says that if we have a right triangle, draw it here, with side A, side B, and side C, the Pythagorean theorem says that A squared, side A squared, plus side B squared will equal side C squared. And you can rearrange that to solve for one of the short sides if you wanted to as well. Let's say we wanted to set it up for A squared, we just move the B squared to the other side and we get C squared minus B squared. So we can write it to solve for the hypotenuse, or we could write it to solve for one of the short sides. And again, only in right angle triangles. Now, if we were labeling the corners or the angles of this triangle, we would label them with capital letters across from the same side. So if I match these up, side B is here, so that means this must have been angle B. Side A is here, across from it, that must have been angle A, and across from that must have been angle C. We use capital letters for angles, small letters for sides. Why do we need to know how to label a right angle triangle? Well, in grade 10 you learned SOHCAHTOA. And SOHCAHTOA is something that helps you remember the three primary trig ratios. And these three primary trig ratios are sine of an angle is equal to the ratio of the opposite and the hypotenuse sides. Cos of an angle is equal to the adjacent over the hypotenuse. and tan of an angle is equal to the opposite over the adjacent. And the SOHCAHTOA comes from the letters involved in each ratio. S for sine, O for opposite, H for hypotenuse. Same for Ka and Toa, CAHTOA. And those three ratios are the relationship between angles in right angle triangles and sides in right angle triangles. So the trigonometry we did last year was that if you knew two sides, you could solve for an angle. If you knew an angle and a side, you could solve for the other side. Once you have two sides, you could use Pythagorean theorem to find the last side. But this gave us a relationship between angles and sides in right angle triangles. How we found angles using this ratio was we isolated for the angle. And the way we did that was we used the inverse trig ratios. If we knew the opposite and the hypotenuse side, we could use sine inverse of opposite divided by hypotenuse to find the angle. If we knew the adjacent and the hypotenuse, we could use cos inverse of the adjacent divided by the hypotenuse to find the angle. And if we knew opposite and adjacent, we could use tan inverse. Then we got into word problems, and word problems involving angles of elevation and angles of depression. And the way angles of elevation and depression work is they work from your line of sight. So let's say we had, this is my eye. Let's say I was looking horizontal to the ground, and I was looking up at the top of an object. My line of sight would move from straight across or horizontal to the top of the object. And that angle that I create by changing my line of sight is an angle of elevation. Elevation means up. Depression is the opposite, down. I'll draw my eye again. And there's my line of sight, horizontal, perfectly horizontal. And I look down at my object. And the change in my line of sight is an angle of depression. So drawing an angle of elevation, angle of depression from a horizontal was an important piece of word problems in trigonometry, and it will again be an important piece of word problems in trigonometry this year. Acute, obtuse, and oblique angles. Acute means less than 90. So you've got an angle that's less than 90 degrees. Obtuse means over 90 degrees, but less than 180 degrees. So that means we've got something that looks like this. And oblique or reflex would be over 180, under 360. How do you draw that? Well, there we are. All right, that's all the prior knowledge. The new piece for the beginning of this lesson is the secondary trig ratios. Now, the primary trig ratios were sine, cos, and tan, and those were the ones that were on your calculator, and you can use them by using the buttons on your calculator. But there are also three more ratios, and they're related to the primary trig ratios. And the way they're related, well, I'll show you here. Let's say we have a triangle ABC, and we know the side lengths are 5, 12, and 13. Well, if I used A as my reference angle, I could find the three primary trig ratios: sine of A, cos of A, and tan of A. These are the primary trig ratios. And sine of A would be opposite over hypotenuse. Cos of A would be adjacent over hypotenuse, and tan of A would be opposite over adjacent. And if I label this triangle with OA and H, I could find those three ratios. So let's do that. We have angle A as our reference angle, our 90 is angle C, which makes 13 the hypotenuse, the one across from the 90. 12 is the other side touching our reference angle A. That becomes our adjacent side, which leaves 5 is the angle side across from our angle as the opposite. Now the hypotenuse will always be the hypotenuse. The one across from 90 never changes. O and A flip based on whether we're talking about angle A or angle B. If I were to label this triangle from angle B, this would be my opposite and this would be my adjacent. Just keep that in mind. Now that we've labeled OA and H, to find the ratios, two equal signs on the same line, ooh, not great, O over H. Sine is O over H, so that would be 5 over 13. So the first ratio, my sine ratio, is 5 over 13 for angle A. For angle A, the cosine ratio would be 12 over 13, adjacent over hypotenuse. And tan of angle A would be O over A, which is 5 over 12. And those are the three primary trig ratios. Those are the ones you used all last year. The secondary trig ratios are related to the primary trig ratios. And here's the secondary trig ratios. Are you excited? The first one is called, I'll write it in words, cosecant. And if it were a button on your calculator, it's not. But if it were, it would be CSC, cosecant. And if we did cosecant of angle A, cosecant of angle A is the reciprocal of sine, 1 over sine A. Reciprocal means flip the fraction. So sine A is a single term. If you were to write it as a fraction, it would be sine A over 1. If we flip it, it becomes 1 over sine A. Coincidentally, the way we find the cosecant ratio is we take the O over H and we flip it. Because if it's 1 over sine, then it would also be the reciprocal of O over H, which is H over O. So the ratio would be hypotenuse over opposite, which is 13 over 5. Or you could look here, the flipped sine ratio, 13 over 5. You might be able to guess how we're going to get the other two secondary trig ratios. We're going to flip cos and we're going to flip tan. Excuse me. But what are they called? Well, the reciprocal of cos is called secant. And its designation is SEC. Secant of A is 1 over cos, which is H over A. And H over A would be 13 over 12. The last one, you might be able to figure out a pattern here. I don't know. Let's see. We got sine and cosine. We've got secant and cosecant. These seem to have pairs. We've got tan. Where's tan's pair? Well, cotangent. Cotan of A. So we got sine and cosine. We got secant and cosecant. We got tan and we got cotan. Neat. Cotan's 1 over tan, which would be A over O, which would be 12 over 5. So now we've got 6 trig ratios. We got sine, cosine, tan, cosecant, secant, and cotan, or cotangent. We're going to split this lesson into 2 video parts. So that's it for part 1. Make sure you watch the second video, part 2, for the rest of lesson 5.1. Thanks for watching, and I'll see you next time.